Well, it is a great pleasure and privilege to introduce you to a friend of ISCAST, more than a friend of ISCAST, a distinguished fellow of ISCAST. Dr. Jennifer Wiseman is coming to us from Maryland, where she works as an astrophysicist, an author, and a public speaker on faith and science. Jennifer studies the formation of stars and planets using telescopes of one sort or another. So she's a physicist from MIT, and in fact, before she finished her doctorate, I think, she discovered a comet which is called Wiseman-Skiff. So she's now a leading astronomer and astrophysicist in the United States. Many of you would know of the Hubble Space Telescope, those extraordinary photographs that we've seen from the last 20 years or so, although you've probably heard about the Hubble more recently in that the James Webb Telescope has now started sending us photos as well. Well, back to the Hubble. Jennifer is the senior project scientist on the Hubble Space Telescope, so she works for NASA. And she's also been very instrumental in the dialogue on ethics, science and religion of the American Association for the Advancement of Religion. So will you please welcome Jennifer as she talks to us about learning from an amazing universe, wonder, purpose, beauty and life. Thank you, Jennifer. Over to you.
Thank you. I am so happy to join this gathering. Chris mentioned I have been to Australia once a few years ago and just loved the people that I met there and the places I was able to see, and I hope to be able to return. I'm grateful for ISCAST and the work that this group is doing and the connections it's making. I'm happy to share with you some of what we're learning by looking up in the heavens, and I'll be sharing with you today from my own personal perspective, not the organizations that I work with, but I will clarify that that's the American Association for the Advancement of Science in the US that has this dialogue on science, ethics, and religion program, which I recently directed, and it is a very active program. So I hope you look that up as well. What can we learn from this amazing universe? Well, one is that, as I understand, you have beautiful weather there, so you're enjoying the sunshine from our nearest star, and it was hard to get you to come back in the room. So I understand that you are already physically experiencing some of the beauty and wonder of the universe just by enjoying the lovely weather right there in your part of planet Earth. But let's go a little bit farther, a little bit deeper than that, and see what we're learning and see what kinds of questions and reactions our discoveries in the universe cause in us and how we might respond to what we're learning. I always like to start with this picture. This is an image of stars. It's a dense cluster of stars called a globular cluster. And it is a region in our own galaxy where the stars are held close to each other in this very extensive clump because of the mutual gravitational pull. So our own sun, which is a star, is not in such a crowded region. These stars are at least 4 times closer than our sun is to any star in our neighborhood. But in a globular cluster, there are many, many stars, and you might be asking yourself, well, if they're held together close to each other by gravity, why don't they all just collapse into one humongous megastar? And the reason is that they have some individual motions, like a swarm of bees, in addition to that attractive pull of gravity. So they stay close to each other and bound in this way, but don't generally all clump together. If we were looking at this group of stars from most telescopes on the ground, the light would all blend together, so you wouldn't see the individual stars. But this gorgeous image was taken with a telescope in space, where you can actually get the sharpness that you need to see the different stars. And you can tell by looking at them that stars are not all the same. They differ from each other in color, and in brightness. And in this case, most of these stars are more or less the same distance from us within this same cluster. So the different brightnesses are not just because of maybe different distances of the stars, but rather that from intrinsic differences. The different colors reflect different temperatures in the outer atmospheres of these different stars. And astronomers can go even deeper and do spectroscopic analysis of these individual stars, since we can resolve them and discern something about the composition and the age of each one of these stars. I look at this picture and think of it like it looks like a collection of gemstones to me, just beauty and magnificence. And you'll all get extra credit for the conference if you can figure out which New Testament verse says that star differs from star in splendor. So I'll hand that award responsibility over to the COSAC leaders there. Anyway, well, I'm just joking here, but I just want you to get a glimpse of how many stars are filling the universe. We think that there are about 200 billion stars in our own Milky Way galaxy, and there's at least 200 billion galaxies in our observable universe. So you can go ahead and start doing the mathematics there and understand that our universe is very rich, and our sun and solar system is just one small part of a very extensive universe, and a beautiful universe. We now understand the activity going on, that stars are not permanent structures. They are forming continually in these interstellar clouds of gas and dust. Here's a region of star formation where that clump of massive stars in the middle, that cluster, has recently coalesced out of interstellar gas and dust. This is what I study. That's my expertise, is in star formation. And in regions like this, the most massive stars form the fastest. They are clumps of gas collapsing under their own gravitational pull. And if there's enough pressure in the middle of that clump of gas, the pressure will cause a reaction called fusion, which causes the hydrogen atoms, which make up most of the gas, to fuse and form heavier elements like helium, and in the process release photons of light. So that is what a star is doing. It's a little factory of fusion going on, where lighter elements are fusing, creating heavier elements, and also releasing photons of light. For the most massive stars, the energetic photons can escape eventually the star and reach the surrounding leftover gas and ionize those gas atoms. And when those atoms recombine, they emit colorful visible light, such as you see in that remnant gas in the outskirts of this image. The winds coming off of these stars also tend to blow away some of the wispy leftover gas and carve the denser structures into these pillars that can hold on a little bit longer as the dense clumps protect the wakes behind them as they point toward these massive stars. And so we see activity as well as beauty as we look into the heavens with our different kinds of telescopes. I love the universe. I love studying space. I've always been curious about space. Here's me with a small model of the Hubble Space Telescope, one of many telescopes that are now in space, and a Hubble image of the Whirlpool galaxy behind me there. But I didn't always grow up thinking I would be a professional scientist. I didn't know anything about that. I grew up here in the middle of the United States, in the state of Arkansas, on a family cattle ranch. And this is me bundled up in a cold winter day feeding our cattle. So we didn't know any scientists. My parents were not able themselves to go to university, but they wanted to make sure their children were able to get that kind of a university education. So I was able to go. But I love just wandering around forests and streams and exploring the natural world. I still go back to that farm as often as I can and enjoy, every day is different. Every season is different. It's a new world if you keep your eyes of wonder open to notice what's happening in the sky, notice animals, wildlife, notice streams and flowers. I love the natural world, and I think that's what attracted me eventually to go into science, because science is the kind of ordered study of the natural world. But I was also encouraged greatly by my teachers growing up, by my family to, maybe even do unusual things and reach high. So they were okay with me going on and studying something unusual like physics and astronomy. And my church family growing up, I grew up in a Christian family, and though we didn't know anything about formal science or scientists per se, we did understand that creation is God's good gift to us, and that God is responsible for this beautiful creation in which we live. And so it was kind of natural then that the study of science would be seen as a good thing, a way of studying God's handiwork and studying the details. So I always felt that science was a good thing. And when there were questions as I went on in science where there seemed to be maybe some difficult discrepancies between what I was taught in scripture and what I was learning through science, I always took to heart what our ministers, pastors told us as I was growing up from the church, that God hasn't given us all the details in scripture. And that's why he wants us to use our minds to study and learn more about the details of everything that have not been fully explained in scripture alone. So that kind of has opened up my mind since my days of being a student, to realize that studying the details of the natural world with science is a gift and complementary to the truths that we are given in scripture about the nature of God, the nature of ourselves, and the wonderful gift we have of God incarnate in Jesus Christ. So we do live in an incredible universe as we are learning more and more with our telescopes. And this inspires a sense of wonder and a sense of awe. I certainly feel that as I look at the images that we're gathering from telescopes in space and on the ground, and even on the micro scale. So astronomy tends to look at the macro scale, but as we also are learning more and more about what's going on the micro scale, even on our own planet, we can be filled with a sense of wonder, awe, and curiosity, and sometimes even bewilderment as we're trying to understand how this all fits together. The reason we're being able to see more and more in the micro scale and the macro scale is often technology. So technology can be used for good things or bad things, but in the case of scientific discovery, I think that's often a good thing. So here we have an image of astronauts who are servicing the Hubble Space Telescope, as they did several times over the last few decades, repairing instruments, putting in new science instruments and new other components over and over again, keeping that observatory fresh. And on the last servicing mission, one of the astronauts brought up with him a model of Galileo's telescope from 400 years ago. So here you see in the interior of the space shuttle, you see the controls, you see the model of Galileo's telescope in front, and then out the window you see the Hubble Space Telescope, where the shuttle had been docked with Hubble for a few days as the astronauts were going in and out from the pressurized space compartment to do servicing tasks. And it's this advance in technology. You can see right in front of you, Galileo was the first person we know of who took sort of recorded systematic scientific observations of space with a telescope. And then in the centuries since, the technology of optics has improved to the point where we have these sophisticated telescopes observing different wavelengths of light in space and on the ground. And as that technology has advanced, our understanding of the universe has advanced greatly. And then that inspires other kinds of human thought as well, not only science, but enriching our understanding of beauty and of curiosity, our even music, poetry, theology, all of these things, philosophy, are enhanced by scientific advances that are often aided by technological advances. So these things go hand in hand. We use different kinds of telescopes, telescopes in space, telescopes on the ground. So the most famous telescope in space, as you see there on top, is the Hubble Space Telescope, having been in orbit around Earth for more than 32 years. It's still going strong. And we also have other telescopes in space and other telescopes on the ground. And they are all complementary. They have different capabilities. So on the lower left is an example of optical and infrared telescopes on the ground. These are the Keck telescopes on the top of Mauna Kea, a dormant volcano in Hawaii. We hope it's dormant. And on the lower right is the ALMA array of radio telescopes that perceives millimeter and submillimeter wavelength emission, often being emitted from the dense interstellar clouds and galaxies where new stars form. So we use these different kinds of telescopes that see different kinds of light or have different fields of view, see different swaths of the sky. We use them in complement to give us a more complete picture or understanding of what we're trying to learn, whether it's about planets in our own solar system or other star systems or galaxies, or even the universe as a whole. And now we have a new major space telescope. I think you've heard it mentioned already. The Webb Space Telescope, which was launched on Christmas Day in December last year and took a few months to get it to its deep space destination, but now it's operating very well. And you see the graphic of it there. It's got a very wide mirror and it's got several layers of shields there on the bottom that are always between the telescope and the sun and the Earth to keep it cool, because this is an infrared light telescope. And in order for it to pick up the faintest infrared light from the distant universe, it has to be kept extremely cold. Here's a view of the launch of that telescope from South America, and some NASA officials there looking both excited and anxious as they watched the launch at the latter part of last year. And there it is in the place where I work. The Goddard Space Flight Center has a large clean room where the Webb telescope mirrors and some of the instrumentation were assembled. And it was kind of neat for me to watch that whole process going on. And then eventually it was shipped away from the Goddard Space Flight Center and shipped to South America for actual launch. Here's a comparison of these two briefly. So Hubble is on the left, the Webb telescope is on the right. They actually are complementary. So we're very excited that we're going to have both of these, as well as other telescopes, working in complement for hopefully quite a few years to come. The Webb telescope has a wider mirror that's divided up into segments so that it could be launched inside an available rocket fairing. But it then has unfolded into this 6.5 meter diameter mirror, very sensitive in infrared light. The sharpness or resolution you get with a telescope depends on the wavelength of light you're looking at and the aperture or the diameter of the telescope mirror that you're using. So if you're looking at longer wavelengths of light, like the Webb telescope does, to get the same sharpness that you get with Hubble, you need to have a wider diameter mirror. So Hubble and Webb both get a similar sharpness or resolution of images, but Webb can see different kinds of light than Hubble sees. So at the bottom, you see kind of the different extents of wavelength coverage. The Hubble telescope sees the visible colors of the rainbow, from red to blue, and even bluer than blue into the high energy ultraviolet part of the spectrum. The Webb telescope which is also called the James Webb Space Telescope, or JWST, sees red light, but then on into the infrared, farther than Hubble can see in the infrared, and into the near and mid infrared wavelengths of light. So Hubble and Webb see different kinds of light by design, and that gives us different kinds of information about what we're studying in the universe. Webb is also a long way away. So Hubble is in low Earth orbit. It's not very far above the Earth, about 550 kilometers or 350 miles, more or less, orbiting about every 97 minutes, a complete orbit around planet Earth. It was put there because it was always intended to be serviced by the space shuttle that can only do low Earth orbit. And it was put into orbit by astronauts on the space shuttle. The Webb telescope is over 1 million miles away at a region in deep space called L2, the Lagrange point, and that keeps it always in line with the Earth and the Moon. Webb is orbiting the Sun along with the Earth, and always keeps its sun shields between its telescope and the Earth and the Sun. Sorry, I should say Webb is always in line with the Earth and the Sun as the Earth orbits the Sun. So Webb is a long way away and probably won't be serviced by astronauts, but we are grateful that it seems to be working very well. All right, so here's an example image of the Webb telescope of the Carina Nebula. Just beautiful contrast of the interstellar gas where stars form and the region above it that's being impacted by winds and radiation from massive stars that have already formed that are off the top of this image. Just the exquisite detail here makes this a gorgeous image. And then let me just back up here a little bit. We see the contrast by looking at the Eagle Nebula, sometimes called the pillars of creation, with Hubble and Webb, and you can see how they give us different kinds of information. So the Hubble image on the left shows us these amazing pillars of dust carved out by massive stars recently formed that are off the top of this image, but we know the lower mass stars that take longer to form are still forming inside these dense pillars, but we can't see into them because the dust blocks the visible light. On the right, with the Webb telescope, looking in infrared light, we can see through a lot of that dusty veil in this region. We see a lot more stars, and we can even see into these pillars and see some of the hot spots where stars or protostars are coalescing and forming, especially up near the tops, the dense tips of these columns. So astronomers use this information, all of it, to learn more about regions like this, and we're grateful to have different wavelengths of light to give us complementary and extended information about regions that we study like this. We also use, closer to home, we can even use probes. So in our own solar system, we use telescopes to study other planets and moons, but we can also send mechanical and robotic probes. So here's the Perseverance rover on the surface of Mars with all of its machinery, cameras, equipment. First image shows you the kind of bleak landscape of Mars, but we know that Mars used to have a different climate that supported liquid water, lakes, rivers. Now there's just some leftover frozen frost under the soil. So trying to understand the history of Mars and whether it could have even supported simple life at some point in the past, and trying to see how planets change over time in our solar system is a strong driver for solar system studies these days. All right, so what are we learning with these kinds of tools? Well, for one thing, we're learning that the universe is beautiful. We're also learning that it's active. As I mentioned, star formation is one of those realms of activity. We're also learning that it's enormous and it's progressive. And I don't necessarily mean that in a political sense, but I mean that it's changing. It's becoming more hospitable to life over time. Here's our beautiful Omega Centauri star cluster, but now we know that stars are not eternal. They form, they come and go. Here's an example of an image of a region of the sky taken with a telescope on the ground, where you get a much wider field of view than you can get with a space telescope like Hubble. And many of you may be familiar with this region. This is the Orion constellation. When I showed this picture in Australia a few years ago, somebody said that it was upside down. And I was like, no, it's not. Because you see, when we look at it from different vantage points on planet Earth, we see slightly different angle and orientation of these constellations. But nevertheless, I hope you recognize Orion with the bright red giant star Betelgeuse up near the upper part of the image, and the bright blue star Rigel at the bottom. And then in the middle of the constellation, you see some fuzziness around the different stars. And if we look more closely at them, we can look at more detail. Astronomers call anything fuzzy a nebula. So if we look at this nebulous region where I've got an arrow pointed, with the Hubble Space Telescope, we don't see the wide field of view like you see here. You see only a small region where the arrow is pointing, but you see in more detail. So the next image shows you what looks like one kind of reddish star there in Orion's sword actually looks like with a space telescope. And this is what you see with Hubble, is a nebula that's not just one star, it's several massive stars that have recently formed in this nebula of gas. And at least one of them is massive enough that it's got very energetic photons coming out and hitting the surrounding gas, ionizing it and creating these beautiful colors. So astronomers look at something like this colorful nebulae and say, wow, the universe is active, stars are still forming, but and it's beautiful. So this is an example of activity. Now, if you look even more closely, you find that there are still smaller stars or protostars trying to form, which is very hard in this now torrent of turbulence caused by the stars that have already formed. But we'll blow up just a couple of those smaller things you may not have noticed. And as you look, you see these are smaller stars still accreting material from the surrounding gas. And they're surrounded by these dark disks. Here's a couple of them in different orientations. One of them is face on at the bottom. One of them is, we're looking at it kind of edge on. And it turns out the diameter of these dusty disks around these infant stars is about the same as the diameter of our solar system. And so we now know that stars form with these disks of debris, this leftover dusty material in orbit around them. And planets actually form out of this material. So the study of planet formation is a very hot topic in astronomy right now. And we know there are planets around other stars because over the last couple of decades, we started discovering many, many of these exoplanets. That means planets outside our solar system. And we know now that they form along with the star in disks like this around young stars. We've discovered thousands of these exoplanetary systems, not through beautiful images like this so much. This is an artist's conception of a real planetary system that was discovered by not taking a picture like this, which is very difficult, but rather seeing how the parent star was dimming periodically as the orbiting planets went in front of it and blocked out some of the starlight. So these observations of transits of planets around other stars is a very strong way of identifying exoplanets and also studying their atmospheres as the light from the star passes through the outer realms of the atmosphere on its way to our telescopes. And we can see what gets absorbed by the atmospheres of these exoplanets. That tells us something about their composition. So here's some example of that transmission spectroscopy taken with the Webb telescope. We like to see the pretty pictures, but a lot of times some of the major science comes from spectroscopy, where we're using the telescope to look at these exoplanets as they pass in front of their parent star. And we see what kinds of emission is transmitted through the exoplanet atmosphere, the outer edges, and what is absorbed. And that tells us what's in the atmosphere. So in this case, the exoplanet we know has in its atmosphere carbon dioxide and carbon monoxide and even water vapor. And it's things like this that are helping us to understand the nature of exoplanets and helping us to understand whether other star systems and their planets are similar or different from our own solar system. It's a very exciting and robust field of astronomy now, the study of exoplanets. We now know that old stars also are not permanent. They begin to run out of that inner fuel for fusion after some time. For smaller stars, that can be billions of years. So here's a smaller star that's become unstable, is releasing its outer atmosphere, and in this case, in a kind of bipolar fashion. So it looks kind of like a butterfly. We call this the butterfly nebula. It's not only beautiful, but this is very important because the heavier elements that the star has been producing inside itself for all its lifetime are then expelled this way and enrich the interstellar medium and subsequent generations of stars. The most massive stars get so unstable that they actually explode. So this is the Crab Nebula. It's the leftover debris from a star that exploded about 1,000 years ago. And the different colors of the debris are showing you different elements that were forged in that star and in the explosion, and now can be picked up by subsequent generations of stars and the planets that form around them. We know that our own sun and solar system are not first generation, that we're taking advantage of the fact that stars came and went before our sun to produce the heavier elements that enabled planets like our Earth to form with what we need for life. So I think of stars as marvelous examples of God's factories producing what we need for life. And all this material fills the volume of galaxies. This is an example of a galaxy that can contain hundreds of billions of stars, the light all blending together from these stars. And you can also see in the arms the bright hot spots, these nebulae where stars are forming. And if you look carefully in the background, you'll see other galaxies. So I think galaxies are absolutely spellbinding and beautiful. We can't get outside of our own galaxy far enough to take a selfie, so we have to look around from inside. And this is what we think our own Milky Way galaxy looks like. And toward the bottom of this image, you see an arrow where our own solar system, our sun and our planets, like where we are right now, inhabit a region near one of the spiral arms, about 2/3 of the way out from the center of our own Milky Way. So this is where we are now in our own galaxy. And now we can look out and see other galaxies. Some are face on, some are edge on. Many like these are full of dust and gas where stars are continuing to form. And if we look in ultraviolet light, we can see those bright hot spots. These are some samples of different regions of different galaxies showing you in ultraviolet light from Hubble where these nebulae are, where new stars are forming vigorously in these other galaxies. Some galaxies merge. We now know that galaxy mergers were common, especially in the early universe. Galaxies would be pulled together by mutual gravitational pull, and that results in bigger galaxies. And we know our own Milky Way is the product of some previous mergers and will be merging with the Andromeda galaxy in a few billion years. So our universe continues to change and grow. Here's a merger a little bit farther along. And we know that the universe is enormous in both space and time. Here's my favorite deep field that's showing you a picture from Hubble, not of stars, but of other galaxies outside our own. So every little dot of light here could contain hundreds of billions of stars. And this is just a tiny little swath of the sky, like looking through a drinking straw. Imagine this extrapolated around the whole sky. Any direction you look, you see something similar to this. It's hard to imagine the richness of our universe. Here's a deep field produced by the Webb telescope. And one of its major goals is to look deeper than Hubble, because some of the more distant galaxies, the light becomes reddened on its trek to our telescope, sometimes far into the infrared part of the spectrum where Hubble can't even pick it up. These bright spikes are foreground stars in our own galaxy, but all the other things behind them are other galaxies. And in fact, if you pull some of these galaxies out of the Hubble deep field and kind of line them up by their distances, you see that galaxies have changed over time. The more distant galaxies here have been put in the circles onto the right, and the nearby galaxies in the circles to the left. And since it takes time for light to get to us, those more distant galaxies, we're seeing them as they were earlier in the universe, closer to the beginning of the universe. And you can see that they were smaller, less ratty looking. Over billions of years, they merged and formed bigger galaxies. And we can also tell that the compositions of the stars and gas in these galaxies have gotten more complex over time with generations of stars. So we can tell that the universe over time has matured over billions of years. It's continuing to change with the production of stars within hundreds of billions of galaxies, and those stars creating heavier elements, which enable planets to form around subsequent stars. And these heavier elements and planets provide conditions for life to thrive that are needed for life to thrive on at least one planet. So you might ask then, does that mean that the universe has a purpose? And with this, we jump from the science, which most astronomers would agree on everything I've said, to a question that's beyond science. Is the universe pointing to purpose or not? And can science even answer such a question? A project of the Templeton Foundation a few years ago asked some thought leaders years ago as to whether they thought the universe has a purpose. And these are thought leaders around the world who generally agree on the science picture that I just described to you about the age and composition of the universe. But when asked whether that implied the universe had a purpose, they had very different opinions. Here's some of the one-word answers from some of these people you may recognize. And then with each one-word answer, they also provided a short essay, which I think are really very intriguing to read if you can find them. But you see that I'll pull out some examples here. Professor Atkins, a scientist, said when asked, does the universe have a purpose? He says no. In the absence of evidence, the only reason to suppose that it does is sentimental wishful thinking, which underlies all religion. And this is an unreliable tool for the discovery of truth of any kind. So that was his reaction. When Professor John Haught of Georgetown University was asked the same question, his answer was yes. In fact, the fact that we're even asking such a question at all suggests that there's an affirmative answer. The impassioned search for meaning, perhaps our species' most distinctive trait, is not a longing that lifts us out of the universe or takes place outside of nature. This thirst for meaning is actually part of who we are as part of the universe. So it might actually point to there actual being something we might call purpose. The fact that we're even asking for it, the fact that we're thirsty signifies there might be something real in water, that kind of thing. And when Jane Goodall was asked this, and she won the Templeton Prize recently, she said, certainly the universe does have a purpose. She says, of course, science typically scoffs at any belief in a God and tells us that this is just a God gene and that the tendency towards belief is simply part of our biological makeup, as inevitable as the human spile. And yet, even if this were so, we would still need to ask why. Why are we programmed to believe in a God? And why are the laws of physics designed to make life ever more complex? And by the way, where did those laws of physics come from? So you see the answers to the philosophical questions can be different, even amongst people who look the same way toward what the science can tell us. And I would not be the first person to say that we should beware of what was called nothing buttery. In other words, anything that says we are nothing but our chemical or our genetic nature or our neurological makeup. That's not true. We are a large combination of our biological traits as well as our environmental shaping. And so beware of any simplistic scientific explanation for what we are or why we do or think what we do. All right, I need to wrap this up soon, so we have some time for Q&A, but let me just spend just a couple more minutes talking about whether science and theology can come to complementary conclusions. The late Sir John Polkinghorne, a physicist who became an Anglican priest, he said that science and theology are both concerned with a search for truth, that they complement each other rather than contrast one another. Of course, these two disciplines focus on different dimensions of truth, but they do share a common conviction that there is truth to be sought. And so it's quite interesting that science and many branches of theology are actually kind of in similar tracks. And many people are surprised when they find out that when I went to MIT as an undergraduate student, that MIT is filled with vibrant fellowship groups of student religious commitment, different Christian groups and other faith traditions. that MIT, perhaps more than any other American university, has very, very active faith communities. And part of it may be because the way scientists understand that there are right and wrong answers, there is truth to be sought, is quite compatible with many faith traditions, including the Christian faith tradition, of there being truth to be sought and understood and grasped. And then when we think about the people involved, Dr. Nancy Edelman, a professor of psychology at Catholic U, said that scientists and people of faith speak a common language, which is awe and wonder about the world at large. And so we can meet on common ground and consider that common interest. Let's think about our own planet Earth. Many times people think about the universe and how many galaxies and how old it is and how many stars and even planets there might be, and start feeling very insignificant. So are we significant? That's another whole talk I can give. But our responses to the grandeur of the universe can span a huge range, from wonder and awe to bewilderment and feeling insignificant, to praise to God or loss of faith or gratefulness or curiosity. And all of these things are certainly valid human responses. I think of Blaise Pascal back in the 1600s, a person of faith himself, but when he was considering time and the short duration of his life swallowed up in the eternity before and after, he couldn't figure out why he happened to be in this time and not some other time, why here and not there, by whose order and direction have this place and time been allotted to me. The eternal silence of these infinite spaces frightens me. I think I can identify with that. Even Carl Sagan, the famous astronomer, said, "Who are we? We find that we live on an insignificant planet of a humdrum star, lost in a galaxy, tucked away in some forgotten corner of a universe." Many people feel that way, but I choose to feel more as the psalmist said. The psalmist was looking up at the heavens, not knowing about galaxies, but seeing many stars, and said, "O Lord, our sovereign, how majestic is your name in all the earth. When I look at your heavens, the work of your fingers, the moon and the stars you've established, what are human beings that you're mindful of them, or mortals that you care for them?" There's that sense of insignificance. But he went on to say, "And yet you've made them a little lower than God and crowned them with glory and honor. You've given them dominion over the works of your hands. You've put all things under their feet." Now, obviously, we didn't have and don't have now hands-on dominion over other stars and their planets, but the knowledge of science is a kind of dominion, and I think the kind of dominion that God gives in the sense of stewardship. It's knowledge to be used to honor God, and that's a gift, and that shows us that we are significant, not because of where we are in space and time, but because that we exist at all, that we're a product of the universe, which seems to be evolving toward life, and our consequential ability to contemplate good, evil, and our place and purpose in the universe. And I would go even farther to say that God has given us not only this ability to understand and contemplate, but that God has shown us God's love to us by giving us life and coming to us in Jesus Christ, who came that we might have life and have it to the full. So how should we respond? I think we should give praise, and we feel humility and awe. I think we should care for our own planet and all its inhabitants as good stewards. And I think we should keep exploring and learning, that this surely honors God and teaches us more about the riches and the depths of God's love and power. I think I'll move on. The inspiration of serving others. This is a colleague of mine who shares the knowledge of the universe with her friends who live in an orphanage here and love to hear about space. And so the knowledge that we have from science can uplift the spirits of others. Here's a visually impaired student enjoying through touch, learning about the universe as many of us do with our eyes. And as we continue, there's lots more new discoveries and new mysteries and new surprises ahead of us. We recently detected the most distant individual star ever detected that we could resolve in a galaxy. Most of the time in distant galaxies, we only see multiple stars. We've recently detected gravitational waves, disturbances in space-time, traveling through space. We expect many more of these detections. We've even imaged the bright light encircling a black hole. So there's lots more to discover. I'll close with this list of good resources. Maybe you can take a picture of this. These are books and organizations that I particularly like, and I'll point out ISCAST there, but a similar organization in the US is called in Canada is called the American Scientific Affiliation, asa3.org. There's a Society of Catholic Scientists, the DOSER program previously mentioned. You can check out the resources there at science-religion-dialogue.org. And I'd also mention biologos.org, looking at the harmony of the Bible and science. Scienceforthechurch.org is just what it sounds like. The Faraday Institute for Science and Religion has wonderful seminars and resources. And if you are or know a professional Christian astronomer, check out our Christian Astronomers Network. We get together at professional meetings and encourage one another through getting together or through email exchanges. So you can look at the Google site there and join the list. There's looking back at Earth from the space shuttle after servicing the Hubble mission and seeing sunrise behind Earth's wispy atmosphere, the blue arc there, showing us our beautiful but fragile planet that we should take care of. So let's praise God for the universe and for the gift of science that allows us to explore and understand the wonders of creation. And with that, I think we have just a few minutes, but maybe we can take a few questions. Thank you very much.
Thank you, Jennifer, for that. Man, some of those images are just beautiful. And I think for myself, I can appreciate just, I guess, how much more infinitely wondrous creation is.
Yes.
So thank you for that, and seeing how complementary faith and science are. So yes, we'll go straight into questions. Just for context, my name's Josh, and we'll go into the Q&A now. So I guess one of the first questions, how has your own wonder and awe transformed your faith over time, and how you interact with others?
I think as I've learned more and more about just the mind-blowing vastness of the universe in terms of its content, even the number of galaxies, and now we know in our own galaxy that most stars have at least one planet. So that means there are hundreds of billions of planets just in our own Milky Way. And we're now rushing to try to build the technology to understand more and more about the nature of those planets, and could they harbor life? And if other galaxies are the same, it's mind-blowing. And so what I think I take from that is that God knows and has always known a lot more about what's going on than we do. And yet God is not surprised by these things. We may be, but God is allowing us little by little to learn more and more about the richness of the universe, and that these things honor God, whether or not we know about them. And it's a privilege to learn more and more about the creation that we are a part of, but we're not all of. And even discovering, you know, we're discovering new species of life here on planet Earth, even now. And I think that that's just an incredible reminder that God is powerful, creative, and knows a lot more than we do about what's going on throughout creation. And therefore, it can make people feel insignificant, but I think what it should do is make us feel a deeper sense of wonder and humility, and appreciation for God's special revelation to us and his love for us.
Yeah, thank you. In terms of, I guess you were talking before about a lot of the planets that we're discovering, and you're saying how that progressive aspect, there's more possibility of like hosting life in a sense, or it's more hospitable. Is the potential of extraterrestrial life at odds with, I guess, Christianity, and have you engaged with that kind of debate?
Yes, well, it turns out that theologians and other thought leaders have been thinking about this question for many centuries. I don't know why, because we're only just now discovering that there actually are exoplanets. But it turns out that this has been a curiosity for a long time. So you can look into this in more detail. But I think most theologians, even certainly within Christian traditions, but also in other faith traditions as well, come to the realization that if we believe that there's a God responsible for the natural world, then surely the God that's responsible for all the diversity of life on this planet wouldn't be threatened, or our faith in that God threatened if there happened to be life elsewhere. Now, the Christian faith has a very unique aspect of believing that the God responsible for the universe actually became incarnate in human form on planet Earth. So one would need to grapple with, if there were intelligent beings on other planets that were intelligent enough to be stupid enough to sin and all of that, then how would God provide for their redemption? And so there have been many theological debates over the centuries as to whether Jesus Christ on planet Earth, whether the life, death, and resurrection of Jesus on this planet would be redemptive toward life beyond Earth. In fact, C.S. Lewis wrote about this in his science fiction novels as well. So, what exactly is the spiritual state of life beyond Earth? We don't know. And actually, unfortunately, since the distances between star systems is so vast, it may be unlikely that even if there is advanced life beyond Earth, that we ever have meaningful interactions with them, at least under the current physics that we live under. But nevertheless, we can speculate. I do think that we can take something from looking at the variety of life on planet Earth right now, and realizing that as we know more and more about other species, that they have very rich emotional and social lives, thinking of dolphins and chimpanzees and many different kinds of species have much richer lives of interactions and complex thoughts than we've ever thought of before. I think we have to be humble enough to realize that God has interactions with other creatures that we may know nothing about. Even in scripture, it says God's made covenant with the other animals on this planet. We don't know the details of God's covenant with other creatures beyond this planet, if there are other creatures. What we do know from scripture, without a doubt, is that God is responsible for the universe and for all life, and that Jesus Christ's coming, death, resurrection, Jesus Christ is the redeemer of all of creation. So whatever life is out there, whether or not we get to interact with them before Christ returns, we know that it will not be outside of the purview and the redemption of Christ. Do I think there's life beyond Earth? I don't know, but I wouldn't be surprised, given God's generosity with life on planet Earth. There might be life flourishing throughout the universe, but we just don't know that yet.
Thank you. I guess coming back to some of those beautiful images we were seeing coming from, the Hubble and the Webb telescopes, and where you can clearly see God's work in creation there. Do you have, here the question is, any pithy lines to give to non-Christians, or maybe even non-scientific background Christians, to help them see God in these images?
No, I don't, because I think that it's tricky to say, do you see God in the beauty of nature? I think many people see beauty and see grandeur, and we share that, and that sense of curiosity and that sense of awe. But whether you interpret that as some sort of pointer toward God, I think you kind of bring that thought to it ahead of time. I think you can sort of, as you look at the progression of the universe over billions of years, you can ask the question, as I did today, why isn't the universe stagnant? Why is it that it looks like it's been changing over time and developing into an entity that's hospitable toward life, that can actually ask these kinds of questions about itself? That to me is a pointer that's consistent with a belief in God and in purpose, but it's not a proof. And so I think you need something beyond just what we see in nature to really come to the specific beliefs we have as Christians. Because after all, as we look at nature, we also see things that aren't necessarily what we would say is beautiful. You know, we see earthquakes and natural disasters. We see even the animal world that can seem sometimes very vicious, even cruel, and humans being the cruelest of all toward each other and toward other animals. And so just looking at the natural world doesn't necessarily point to a kind of beautiful, wonderful God in a simplistic sense. I do think you can talk about consistency. So to me, the development of the universe toward life that at least on one planet can think about itself is more consistent in my view with a purpose and than a purposeless universe. But that's my own interpretation. As I showed you, that different people can come to different philosophical conclusions. We need the witness of nature, but we also, I think, need the specific human descriptors that we get in scripture about the nature of humanity, that our fallenness, our sin, our need for love and forgiveness, these ring true with our own experience. So the revelations of scripture and prophecy that are specific to human life are helpful. And then, of course, the historical life, death, and resurrection of Jesus Christ is the powerful focus of the gospel, and we need that as well.
We are finishing up, unfortunately, but
Okay.
thank you so much again, Jennifer Wiseman. I guess please thank you with me.